Hello friends, in this session we'll just do a couple of problems to have a good understanding on the application of KCL to solve engineering circuit analysis problem. So let's take the first question. The question is to find the value of Vy if Iz is equal to minus 3 amperes, right? So clearly you can see that our interest will be in this node here, alright? So let us find what all currents are coming inside the node or leaving the node. Now you can clearly see that this dependent current source has a value of 3Vx. So you are having 3Vx which is coming here, and this Iz is also coming here. Now you have to mark the direction of the current which is flowing in this direction. Now I have already told, based on passive sign conventions, for a plus minus polarity like this, for a resistor you can put the current direction in this downwards direction, that is facing the positive side. Let me call that current as I1. Let us write KCL to put this node as 1. Putting KCL at node 1. Putting KCL at node 1, what we get? My 3Vx is entering the node, right? So minus 3Vx. Iy is leaving the node, so plus Iy. Iz is also entering the node, so minus Iz is equal to 0. Okay. So let us find the individual values. We have to find the value of Vy, right? And Vy, based on the sign conventions, is easy. It will be Iy into 1. This resistance is 1 ohm, right? Now let us find what is Vx. You can clearly see that Vx is nothing but the voltage here. So plus sign and plus sign are matching, minus sign and minus sign are also matching. So clearly Vx will be equal to plus 5 volt, and this information is got from the circuit. Alright. Now the Iz value is given to be minus 3 ampere, not plus 3 ampere, minus 3 ampere. So let's put the values here. So minus 3 into Vx value is 5 volt plus Iy minus, and Iz value itself is minus 3, so equal to 0. So what do you get? Minus 15 plus Iy plus 3 equal to 0, which means Iy is equal to 15 minus 3 equal to 12 amps. Okay. Now since Iy is equal to 12 amps, Vy will be equal to 12 into 1, which is equal to 12 volts. Alright. So let us go to the same problem. There is the same circuit with a different question which is to be answered. So the question is, with what voltage to replace? With what voltage to replace the 5 volt source to obtain Vy to be equal to minus 6 volt? Let's take our eraser here and let us rub this. Right? So the question is, they are asking you, let us call this voltage Vs. What should be the Vs value so that Vy will be equal to minus 6 volt? Let me quickly put the given information here. So this is minus 6 volt. Please don't reverse any polarities. You have been given the Vy is equal to minus 6 volt. So just put it directly there. Alright. So earlier also we have seen this. So this is 3Vx here, and Iz is given to be minus 3 amps. Alright. And this is Iy. Okay, let us put the KCL at node once again. KCL at node 1. So this is our node 1. Okay. Now, so minus 3Vx plus Iy, and minus of minus 3 is equal to 0. Right. So let us find out the values. So minus 3Vx plus Iy plus 3 equal to 0. So we have to find what is Iy here, because Vx is unknown and ultimately Vx will be equal to Vs. So if we find the value of Vx, we will get the value of Vs as well. So let us find what is Iy here. So Iy, it is, let us take the diagram here. So this is the voltage. This voltage is given to be minus 6 volt. Right, the resistance is given to be 1 ohm, and Iy is in this direction. So clearly Iy is equal to, what is the value of voltage? It is minus 6 volt. Okay, so just put it directly, minus 6 volt divided by 1, that is minus 6 amperes. So minus 3Vx, right, minus 3Vx, and what is the value of Iy? It is minus 6. So minus 6 plus 3 equal to 0. So what do you get? Minus 3Vx equal to 3. Vx is equal to minus 1 volt, and clearly Vx is equal to Vs, right? That means Vs will be equal to minus 1 volt. Now just take the third problem which is given here. In the third problem, the circuit is fairly simple. You can clearly see if Ix is equal to 5 amps. So they have given Ix value to be equal to 5 amps. You have to find the value of Iy. So Iy is the current which is flowing through the 10 ohm resistor in which you have the voltage V2. Alright. So our interest node will be naturally here because you are having information. So let me call this as node 1. Let us apply KCL at node 1. So for the first problem, let us apply KCL at node 1. KCL at node 1. So clearly Ix is entering the node. So you get a minus Ix. Alright. Now, this current, so you have to put two currents here, right? So let one Iy is already here, and let me put the other current here. Maybe I will put it simply I, right? You are having two currents, so plus I plus Iy equal to 0. Alright. Now based on Ohm's law, clearly you can see the value of I will be equal to V2 divided by 10, and the value of Iy also will be equal to V2 divided by 10 because both the resistance see the same voltage. So this point you are having V2, the two resistance see the same voltage. So now what is the value of Ix? So it is minus 5 plus V2 divided by 10 plus V2 divided by 10 equal to 0. Alright, so you get 2V2 divided by 10 is equal to 5, and that means V2 we will be getting as 25 volts. Right? Now, clearly from the circuit you can see that Iy is equal to V2 divided by 10. Therefore, it is 25 by 10. It is 2.5 amperes. Okay. So, this is a fairly easy problem. You have to just find which node you have to apply your KCL. Now, there is another part to this question. I'll just put it here itself. The second part of the question is, if V1 is equal to 3 volt, you have to find Ix and Iy. Okay, so this is given to be 3 volts. This is given to be 3 volts in the second part of the question. Now, let us put KCL at this node 2. KCL at node 2. Alright. Now, based on this sign convention, clearly I will put here one current I1, and the same voltage is coming here. I will put this current as I2. Okay. Now let's apply KCL at node 2. So what do you get? I2 is entering, so it is minus I2. I1 is entering, it is minus I1. Ix is leaving, Ix is equal to 0. Alright. Now, what is the value of I2 here? I2 is nothing but V1 divided by 10, and I1 also is V1 by 10. So minus V1 divided by 10 minus V1 divided by 10 plus Ix equal to 0, which means your Ix value will be equal to 2 into V1 divided by 10, that is equal to 2. And what is the voltage of V1? 3. So 2 into 3, this is 600 milliamperes. This is 600 milliamperes. Alright. Now, with this, you can clearly find what is Iy, right? You know the value of Ix, and the method by which we have solved the first problem, you will get the value of Iy, and Iy you will be getting it as 300 milliamps. You can try it out for yourself. Alright, so these are a couple of simple problems which we have done, and in the next session we will be starting with Kirchhoff's voltage law, which is also a very important concept in engineering circuit analysis. Once these topics are over, we will be starting with mesh analysis, node analysis, superposition theorem, etc. And everything is basically the application of KCL and KVL. So make sure to understand the concept, and I'll see you in the next lecture. Thank you.